Alrighty, in this video we are going to be talking about how to solve trig equations from 0 to 2 pi. So this is going to be the first video, and then in the second video we'll talk about how to solve equations from negative infinity to infinity, aka your general solution. But first, there are probably 8 types of ways that we could solve a trig equation. The first one, very simple, easy peasy lemon squeezy. We're going to be collecting like terms. So add cosine to both sides and then move that root 3 over, or do whatever you want. But either way, you are going to get 2 cosine of x is equal to negative root 3. Cosine of x is equal to negative root 3 over 2. And then at this point, it's just a game of, do you know your unit circle? So in this case, we know that cosine of x is at negative 3 pi over 2 whenever x is 5 pi over 6 or 7 pi over 6. And these are going to be your 2 answers. Likewise, for number 2, we're starting off easy peasy lemon squeezy again. 4 sine square of x minus 3 is equal to 0. I'm going to add 3, then divide by 4. And then I'm going to take the square root of both sides. Now remember that whenever we take the square root of both sides, that we have plus or minus. We're going to get plus or minus root 3/4, which can be simplified down to plus or minus root 3 over 2. So all of the positive root 3's over 2, and then all of the negative root 3 over 2's. So essentially you're going to get 4 answers. You're going to get your pi over 3, 2 pi over 3, 4 pi over 3, and then 5 pi over 3. So all of that will give us either positive root 3 over 2 or negative root 3 over 2 whenever we plug it into sine. All right, likewise with number 3, another easy peasy lemon squeezy problem where we were just going to factor out a GCF. So move that cosine to the left side is equal to 0. Factor out a factor out a cosine of x. So then you're left with 2 sine of x minus 1 is equal to 0. Now, this is the important part whenever we are doing trig equations. Don't divide by cosine of x. That's going to be illegal. Just keep it like cosine of x, and then keep it as 2 sine of x minus 1. So then we have 1 is cosine of x equal to 0, and 1 is 2 sine of x minus 1 is equal to 0. We know that cosine of x is equal to 0 whenever we have our quadrantal angle at pi over 2 and 3 pi over 2. We know that sine of x is equal to 1/2 at pi over 6 and 5 pi over 6. So those are my 4 answers. All right, so number 4, this is where we kind of get into... it's not hard. It's a quadratic. Hopefully we know how to factor by now. What I'm going to do here is substitute in sine so that instead of looking at this, I'm going to say u is equal to sine of x. So we're doing some sort of u substitution here. So anytime I see sine of x, I'm going to replace it with u. So that I get 2u squared minus 3u plus 1 is equal to 0. The reason why I'm doing this is just because it's a little bit easier for us to look at this right here than this right here. And then at this point, it's just a game of, can we factor this by, let's see, -2, -1. So then use your handy dandy, whatever method you prefer, and then factor this out. We are going to get u minus 1, and then 2u minus 1 is equal to 0. Which means that u is equal to 1, and then u is equal to 1/2. Now, make sure that whenever we solve this, that our question is in terms of my variable x. Right now it's in terms of u. So what I'm going to do here is, remember, we had u be sine of x. So I'm going to replace that. So that I get sine of x is equal to 1. And then sine of x is equal to 1/2. Sine of x is equal to 1 for my quadrantal angle of pi over 2. And then sine of x is equal to 1/2 at pi over 6 and 5 pi over 6 that we saw earlier in number 3. Those are going to be my 3 answers. All right, sometimes you might need to rewrite trig expressions so that it's what we want. So looking at number 5 here, I'm going to replace probably secant square of x, because we know that secant square of x is just 1 plus tangent square of x minus 2 tangent square of x minus 4 is equal to 0. Go ahead and distribute and simplify this. Make your life a little bit easier. So then we get tangent square of x. 3 minus 4 is negative 1. So then probably move that to the other side to get positive 1. And then we have a square. So just like number 2 here, whenever we have a square and we'll take the square root, make sure that you have the plus and minus. So tangent of x is equal to plus or minus 1. And we know that tangent is negative 1 or positive 1 with my pi over 4's family. So this is going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. All right. 6 is where we kind of get messy a little bit, because I can't really solve sine of x plus 1 is equal to cosine of x using my identities that we know. So what we are going to do here is do a little bit of manipulation by squaring both sides. Now here's important parts whenever we square both sides. Whenever we square both sides, at the end, we'll get a couple of answers, but we'll probably have to check for extraneous solutions because we manipulated the original equation. Now, yes, we kind of manipulated 1 through 5 here, but we manipulated it by, let's say, factoring. But because we are putting a square on both sides, we are going to have to check for extraneous solutions. So we have sine square of x plus 2 sine of x plus 1 is equal to cosine square of x. Okay, we have another problem because we have sine of x and we have cosine of x. So what I'm going to do to make my life a little bit easier here is go ahead and change this to 1 minus sine square of x. And the reason why I'm doing that is because I can't really manipulate sine of x right here, because then if I do that, then I'm going to have a cosine square of x. But then I'm still going to have sine of x right here, which we don't want. So 1 minus sine square of x. Go ahead and move everything to the left side. Plus 2 sine of x is equal to 0. Go ahead and factor this. So 2 sine of x plus 1 is equal to 0. So 2 sine of x is equal to 0, and then sine of x is equal to negative 1. Now, sine of x is equal to 0 at 0 and pi. Now, because the question, the instructions, the directions, says it's off from 0 to 2 pi, we're also going to include 2 pi in our answer. And then what we're going to do here is, looking at sine of x is equal to negative 1, we are going to say that x is equal to 3 pi over 2. So, like I said earlier, these are my 4 answers, but we might have extraneous solutions. So what we are going to do here is do a quick plug and chug. All of these are basically quadrantal angles, so it shouldn't be that hard for us to plug and chug, especially since 0 and 2 pi are basically the same thing. So what I'm going to do on the side here is plug and chug. So sine of 0 plus 1 is equal to cosine of 0. We know that sine of 0 is 0. We know that cosine of 0 is 1. 1 is equal to 1. So 0 works, and then 2 pi also works, just because they're cousins of each other. Okay. Looking at pi now, we have sine of pi plus 1 is equal to cosine of pi. Now, sine of pi is 0 plus 1 is equal to cosine of pi, which is -1. 1 is equal to -1 is not true, so that's false. Because this is false, we know that pi is extraneous. Boo. And then finally, we have to look at sine of 3 pi over 2. So looking at sine of 3 pi over 2 here, that's going to be -1 plus 1, which is 0. And then cosine 3 pi over 2 is also 0. So we know that 3 pi over 2 works. So our final answers are going to be 0, 2 pi, and 3 pi over 2. All right, sometimes we might have to deal with multiple angles, and this is where our knowledge of the period is going to come in handy. Now remember that our unit circle goes from 0 to 2 pi, and mostly our period for a regular Schmegler trig function is 2 pi over b, given that it's a sine or cosine function. So here's my problem with number 7. Because I have a 2x inside my argument right here, my period isn't going to be 0 to 2 pi. Instead, my period is going to be from, let's say, 0 to pi. Because if I did 2 pi over b, I'm going to get 2 pi over 2, which is pi. So that means that my period is pi, which means I'm going to loop every pi times. Now, this is going to be important because remember that our equation here, or our direction, says to solve from 0 to 2 pi. So here's what we are going to do. We are going to solve this like a normal sine function, where instead of it being sine of 2x, I'm just going to use u substitution, and I'm going to say sine of u is equal to √3 over 2. Now, we know that when is sine √3 over 2? So we know that is at pi over 3. And then we also know that it's at 2 pi over 3. But remember that this is in terms of u, but we want this to be in terms of x. So technically, if I were to divide this by 2, since I have 2x is equal to pi over 3 and 2x is equal to 2 pi over 3, technically my answer is going to be pi over 6. And then technically my answer is going to be what is that? Pi over 3. Now, here's the thing though. Remember that this right here is only from 0 to pi, because that was my period. Because I also need to account for, let's say, pi to 2 pi, because remember my direction says to solve it from 0 to 2 pi. What I need to do here is add my period. So what I'm going to do here is add pi to both pi over 6 and add pi to pi over 3. So my period was pi. So here is pi over 6. Oops. pi over 6, pi over 3, and then I'm going to have pi over 6 plus pi, since that was my period, and then pi over 3 plus pi, because this was my period. This should be easy for us to probably simplify, so we'll get a 7 pi over 6, and then we'll get to 4 pi over 3. So anytime we have multiple angles here, what we are going to do here is go ahead and use substitution, and then don't forget to account for the period, since our equation or our thing says 0 to 2 pi. All right, finally, number 8, so there are times where your equation probably will not be on the unit circle. So here, I don't know what -1/2 is on the unit circle in terms of tangent. So what I'm going to do here is just use inverse functions and say inverse tangent to get inverse tangent of -1/2. This is the part where, because this is calculator active, we put inverse tangent of -1/2 into my handy dandy calculator, and then let's see, you'll see that, let me do this, you'll see that inverse tangent of -1/2 is -0.46364. -0.46364. Okay, either way, it's a negative answer. It's not in our domain. We don't want that. We don't like that. Because remember that our solution needs to be in terms of 0 to 2 pi, which is what I have in purple right here. Now, remember, just like what we did with number 7, what I can do is just add my period. Now, remember that my period for a tangent function is going to be a little bit different. Remember, that's going to be pi over b instead of 2 pi over b. So instead of adding 2 pi, I'm going to add pi. So here's what's going to happen now. I'm going to get this right here. So inverse tangent of -1/2 plus pi. You could probably see that since my solution's from 0 to 2 pi, that we have another answer. So I'm going to add another pi, aka 2 pi. And we see that that also hits. So I'm going to have two solutions. I'm going to have inverse tangent of -1/2 plus pi, and then inverse tangent of -1/2 plus 2 pi as my answers. That is 8. So essentially with number 7 and number 8, if your answer is not in the domain, probably add your period until you hit 0 to 2 pi. Which is essentially what's going to happen with 9 through 14 here, because we're going to be solving for a general solution for each of the equations. But that's going to be the next video.